Today, I'm going to show you why it's still a good idea to build a DIY lithium iron phosphate battery. What's up everybody, my name is Dan, welcome to Freely Roaming. So in the recent years, there's been a lot of low-cost, commercially built lithium iron phosphate batteries in the market today. You can get 100 amp hour batteries for as low as $350. And I've shown a few of them on this channel. And because of that, it started to seem like it wasn't viable to build a lithium iron phosphate DIY battery anymore. Part of it has to do with the logistics of shipping battery cells across the Pacific. Now, as time has passed, logistics has gotten a little bit better as far as shipping goes. And prices that had temporarily climbed sky high for prismatic lithium iron phosphate cells have started to settle back down. Even with all the shortages, the manufacturing of these cells have not stopped, which has led to a bit of a surplus in supply. So once again, you can get these 280 amp hour EVE cells, the same ones that I use for my DIY lithium iron phosphate battery series. You can now get them again for a really good price. I want to warn you guys, building a DIY battery is not something that everybody should do. In some of these review videos that I've done for these commercial batteries, I've given you guys a lot of options on what batteries you can buy without having to go through the hassle or learn the know-how of building your own battery. But if you're a DIY person, you're going to build your own battery anyways. At least that's how I am. But I will warn you though, it is a potentially dangerous project. You could start a fire, you could have an explosion, you could be injured, and you can most definitely cause severe injury, if not death from it. So be really careful and make sure you know exactly what you're doing before you build one of these batteries yourself. Let me just go through the reasons again why you might still want to build a DIY battery. The cheapest commercially available battery today is still about 28 cents per watt hour. That's about $350 for a 100 amp hour battery. This battery that I built right here, even though it doesn't look like much, this is about as basic of a battery as you can have. It does not have an enclosure. It doesn't have any terminals. It doesn't have anything that you might see in a commercial battery, but that's because this is a DIY project. You can build an enclosure. You can add positive and negative terminals. You can add all kinds of different stuff to this, but this is in its basic form, a lithium iron phosphate 12.8 volt battery with a BMS, and it's got low temperature disconnect as well as Bluetooth connectivity in a really small package. For 280 amp hour lithium iron phosphate battery, the per watt hour cost of this battery is only 18 cents. And this is about the same footprint as what you will find a 100 amp hour battery pack. But of course, that's without the enclosure. Once you add the enclosure, it's going to be significantly bigger. And this weighs about 50-ish pounds, and that's a little more than double what a 100 amp hour lithium iron phosphate battery weighs, but it has almost triple the capacity. So size is another reason why you might want to build one of these. And it is in fact why I still use a DIY pack, even though I have access to commercially built packs. Another reason why you might want to build your own is that you can select your own components. In this particular one, I'm using a RadioB Tech BMS, which is the same one that Current Connected, Overkill Solar, and a lot of these other companies use. It has built-in Bluetooth, it has 2 temperature sensors, and it is capable of outputting 120 amps. Serviceability is another reason why you might want to build another one, because you built it yourself. You know exactly how to repair it, you know exactly how to service it, you know exactly how to replace parts when it's needed. And lastly, it's just a fun project to do. For those of you that have the know-how, that know the safety measures that you have to take, it is really enjoyable to build something and have it work for you. So today I'm going to be showing you how I built this battery using 4 280 amp hour EVE cells, just like I did before in my previous video series. Except this one's going to be very beginner friendly with just 4 cells, a low cost but high quality BMS, and it's one that you can easily buy from Amazon that's in stock, and it's fully programmable, has Bluetooth connectivity, and low temperature disconnect with just some basic know-how. I will say though, the techniques that I'm using today to build this battery will not represent all the best practices of building a battery pack, nor is it meant to be a full tutorial. It's just an educational video so you guys can see the basic components and functionality of a 12.8 volt lithium iron phosphate battery pack. I realized that in my previous video series, I didn't actually go through step by step of how a battery needs to be assembled. I merely showed you the components and then I showed you the battery after it was assembled. In this video, I'm going to show you all of that. Exactly how to connect the battery leads, exactly how to connect the BMS, and how to measure its voltages and how to test, make sure that it's working afterwards. All right, so this is how this package came in this cardboard box. Again, it's well labeled. I always like to show how you receive these batteries in the mail because it's really important to me that it's well packed because they're much more prone to damage during shipping. So I have to say this came really well shipped. It actually came by air, so came by cargo air, so that came pretty quickly. It depends on the type of shipping option you choose. You may or may not get it by air, but it is labeled that it's batteries inside. When you open it, this was shoved into the side here, and this was in a little pouch. I've since opened it, so that's what you get. You get 4 bus bars, and these are just flat bars. They don't have a curve in it, so it doesn't have the ability to expand. These holes are ovaled out. They're rounded out in an oval shape, so they can slide back and forth on the studs of the cells. So that's what you get, and they look like nickel plated. Feels heavy. Steel, or it's not aluminum. It's either steel or copper. And then you get a bunch of flange bolts, or flange nuts is what you get. You get these serrated flange nuts, which I'm not going to use. I went ahead and got just regular nuts and washers, and I'll show you why that is in a minute. So it came with 8 of these serrated flange nuts, and they look to be stainless steel. M6 serrated flange nuts. So then inside the box you have, there's sort of these foam compartments that slide out like this. And each of these have 2 cells in them. And here's what the cells look like. There we go. Here are the 4 cells. These are 280 amp hour lithium iron phosphate cells. From what I can tell, they're really well built. There's nothing bulging on any of the sides, and all the insulated covering is all intact. There's no dents, there's no damage. The QR codes look good. LF280K model, which I believe are Eve cells, but correct me if I'm wrong. And what's cool about these compared to the Eve cells that I've used in my previous build is that instead of just having a threaded terminal here that you have to screw in a bolt, these have laser welded studs. And these are much, much better than having to deal with screwing in a bolt, because a lot of the times they can be stripped. People can bolt them in too tight and it will penetrate the bottom of these. So this is really, really nice. And in fact, there's a video on their website about how they do the laser welding on these. Let's see what's on these batteries. 3.2 volt lithium iron phosphate cell, 280 amp hour, voltage 3.29 volt, internal resistance 0.21 milliohm, Shenzhen Qishou Technology Company Limited. You know the look of one of these cells, really nice. I'm going to use a RadioB Tech BMS. This, I bought this because you can readily buy this on Amazon for about $120. And this is a 120 amp BMS made for a LiFePO4 4S battery. And what's cool about these is that it comes with temperature sensors, 2 of them, and actually there's 3 of them, and I'll show you how I know that, because there's only 2 that are shown here. It also comes with a Bluetooth dongle, and this Bluetooth dongle is how you can tap into all the settings and also read all the outputs of this BMS. And it is totally programmable, which is not ideal for beginner because you can really screw up the programming and have your battery go awry. But for somebody who knows what they're doing, it's really great. You have the B minus and then they call it C minus here. So basically one of these goes to the negative terminal of your battery, and the other one is going to be your negative for the entire pack once it's built. And they're 10 gauge flexible silicone wires, 3 on each side, more than enough for 120 amps. And also comes with the battery sensing leads. What it doesn't come with is doesn't come with these lugs installed. I had to install these lugs myself. It comes with lugs, but I didn't use the lugs that it came with. I used these lugs that I had because they were easier to do. And also it doesn't come with these lugs installed, so you have to do that. But it's just a simple crimping job. You can crimp, solder, or both. I did both. I crimped and soldered. So this right here is all you need. Right here. You know, aside from a few other things, you're gonna want probably build a box to hold them. I'm not gonna build a box for this demonstration because you guys can probably do that yourself. Figure out how to do that. I got 2 of these just 59-cent folders from Target. They're plastic, right? They're just little folders for like little book reports or whatever. And I cut it out. I cut it out to the size of the cell. So I'm going to insert one in between each of these 4 cells just to give us some more added insulation between the two, just in case the insulating wrapper chafes off for whatever reason. You can't be too safe. In the past I've used really thin cutting boards, but I think that's probably overkill. But this is more than enough. Rather than clamping them together like I've done with threaded rods before, I'm just going to use strapping tape. So I'm going to use strapping tape to strap all this battery around so it becomes one piece. And then I'm going to build it all together. So what you see right here is what's going to make up this battery build. Super easy, super simple. You could probably do this in 10 minutes once you have all your parts. Let's get to it. Okay, so the first thing I'm going to do, first I organize all this stuff. So the first thing I'm going to do is I'm going to orient these cells in the proper orientation. So you're going to want to do positive, negative, and then again positive, negative. That's going to give you a series connection to make this into a 4S pack. And then I'm going to insert one of these between these first 2 cells, push them together. So what I'm going to do is I'm going to use strapping tape to strap pairs of these together. So these 2 are going to be taped together using strapping tape, and then these 2 will be taped together using strapping tape, and then the 2 pairs will then get taped together once again. And this will prevent the middle cells from like falling out, because you know, if you just put them all 4 together and strap them together with strapping tape, there's these middle ones are only getting tapes on the side. So I'm going to do this and make sure they're in the right orientation and then tape them up. So just so you guys know, I'm showing you how to put this pack together, but what I'm not showing is I'm not showing you guys what you really have to do before you get to this point, which is you have to make sure that these cells are ready to be put together, meaning that they are well balanced. And just to be 100% sure, some people like to do a top balance, which you can definitely do. What you do is you connect all 4 of these in parallel, meaning connect all the positives and then all the negatives, and let them sit for a good 5 to 10 days to let them all equalize to the same voltage. And then you take a charger that can charge these up to its highest voltage. So the only time when you know they're at the same state of charge is either at the very top end or at the very bottom end, because that's the only place where the voltage curve has any significant drop. So it's really actually hard to know when they're in the middle whether or not they're in the same state of charge. Make sure the tape is sticking really good. And these cells are all sitting nice and flat against each other. We're going to put the bus bars back on. Positive, negative, positive, negative, positive, negative, positive, negative. So now those are on. We'll take our battery sensing wire. We'll take the first red one. That's going to go on. First cell positive, also known as the main positive. I'm going to stick a washer on that and a nut on that. All of this is also documented in this diagram that comes nicely with this RadioB Tech BMS. You can see it shows you how to wire it, and it shows you that the blue 10 gauge wires are going to your main negative. Okay, next one. The first wire next to the red one, that's going to be your first cell. Negative. Washer. Nut. And now you can see why I'm not using these flange nuts and I'm using this regular nut instead. Is because this flange nut's actually a little too big for these lugs that I'm using for the BMS. So I switched over to the non-flange ones. Okay, and then we'll just secure down this second cell positive, as it doesn't need any sensing wires. We'll go and snug all that up later. Next one, the second white one from the red. I'm going to put it right here in the second cell. Negative. A lock washer and a nut. Okay. And then this positive on the third cell just needs a washer and a nut. Again, we'll snug it up later. And the last white wire will go on third cell negative. And that'll get a washer and a nut. And then fourth cell positive gets a washer, nut with nothing on it. And then the only wire left is going to be your main negative or fourth cell negative. You notice I didn't trim these wires at all because these wires are going to measure the voltage. And the longer each wire is, the more resistance it has. Even though it's very, very small in this size wire with this little amount of voltage going through, you will lose some voltage if the wire is longer and gain some when the wire is shorter. So to make sure you're getting the right readings from all four cells, keep those wires the same length. Alright, so now this last one, we're also going to be connecting these three 10 gauge blue wires on it. So that's all going to get snugged up. Right now I'm just finger tight to make sure everything's working. What we got here is this is going to be the BMS. Now this becomes our main negative for the battery. These black wires that come from the BMS, that becomes our main negative for the battery. And this right there is our main positive. So to use this battery, we're going to connect our load to negative here, positive there. That's going to give you a 12 volt battery. And then to activate our BMS, let's plug in our sensing wires. So again, I want to show you how everything is working. We've got our BMS here, RadioB Tech BMS, with our C minus here. This is our main negative. These are the two temperature sensors. So what you would do once you have it mounted up, which I'll probably do something like, I don't know, something like this. And you want to put these temperature sensors somewhere along the side of the battery and then tape it down, because that's going to tell you whether or not the temperature is getting too cold. That's how you activate the low temperature cutoff. Alright, so I got the temperature sensor, one of them taped down here, one of them taped up here. So it'll sense temperature in the low part and the high part of the battery. One of the things that this build isn't necessarily ideal is mostly due to because I'm not putting this in an enclosure and I have the BMS taped right to the side of the battery. Because what happens with the BMS is that under load these can heat up and the heat can transfer into the cells, which means these 3 cells right here could have increased degradation compared to this one. So that's something you want to keep in mind. It's not ideal, but sometimes you just have to do the best that you can under the situation. So here I'm just going to bundle up these extra wires. Like I say, you don't want to cut them shorter, even though it would be neater looking. You want to keep them the same length as to I missed one. Shoot. As to making sure your voltage readings are consistent. I'll just put another one in here. One last zip tie just to keep this main negative up. Alright, let's trim all the zip tie ends. There we go, we have a fully functioning battery. Right there. 280 amp hour. 120 amp BMS, low temperature cutoff, Bluetooth connectivity. So let's let me get the multimeter. We'll do some readings. See what the multimeter says. Okay, main negative, main positive. 13.1, 13.11. Okay, first cell 3.27, second cell 3.27, third cell 3.26, 3.27, fourth cell 3.27. Well, there you go. I think we're done. That's our battery. Alright, this is how you connect to the Qishou BMS app. Once you connect, this is the view you get. I've already got this battery programmed to show that it's a 280 amp hour battery, and it's actually charged all the way full right now. But you can see that the at the very top of the charging curve, these cells are not perfectly balanced. But here I just want to show you guys how this app works. Here you can see the capacity, the temperature, and if you click on that, you get the 3 temperature sensors that show you where they're at in Celsius. Total voltage, which shows you a graph, and it has some historical data, which is pretty nice. Time left, it shows 39 hours, I presume, but it is not being used at all. So you can see power 0 watts. So that's probably just a really big number that it uses. You can actually turn off charging and discharging right here using these 2 little switches. And right now it's not showing any faults, so protection shows none. As you can see, balancing shows balancing. And the programmability of this BMS is really cool, but it's also can be potentially dangerous for a beginner. So I want to show you. If you click on this menu icon and go down to param settings, and now it's going to load all the parameters that you can customize in this BMS. Because I know this is a lithium iron phosphate battery, up on top you see polymer normal, polymer light, LiFePO4 normal, LiFePO4 light. In this particular build, you're going to ignore polymer, the 2 polymer options. These 4 are basically presets that you can use, and it will pre-populate a bunch of the most common information under the protection params. It won't change anything for base params. It auto detects the number of cells, so it's a 4S configuration. And nominal capacity, I chose that to be 280. Galvanometer resistance is 0.01, which is also a default. So if you choose, right now it's set at lithium iron phosphate 4 normal. So if I choose normal, it pre-populates all of these settings. Now if I choose light, it'll drop some of these settings to a slightly more conservative number. you would want to use light if you're trying to extend the life of your battery. But you also have to make sure that if you're going to use light, you're also going to want to program your chargers to charge accordingly to those voltages. But I'm going to go ahead and just use normal. And to do that, you just click the upper right corner checkbox to save it. Now it's going to write all the settings. So if you wanted to customize these, if you know what you're doing, you can customize each and one of these with your own numbers if you want. But I would highly recommend using your own settings. As you can tell down here, it has a cycle capacity at 224. That's auto calculated for 80%, meaning that it'll count how many cycles this battery has, and if it goes down below 224, it'll count as a full cycle. There we go. We'll come back out, and this is the main screen you're going to see. It's actually a pretty nice BMS for as low cost as it is and for as many features as it has. There you go. So you can see building a DIY battery can be a very simple process. I would reiterate again though that you must be very careful and know all about the safety precautions when building a DIY battery pack, especially if you're going to be using it in a mobile environment where there's a lot of vibrations. This build is meant to be a very low cost process, so it does not show optional fuses and breakers that you should install for additional safety measures. Price, as you can see here, is a mere 18 cents per watt hour. That's compared to the cheapest batteries in the market today, which is at around 28 cents per watt hour. And this exceeds the capabilities with low temperature cutoff and Bluetooth connectivity. I have no doubt that this battery will perform in an off-grid environment. I've already done a capacity test of my previous pack built using the exact same EVE 280 amp hour cells. So I'll link it in the corner so you can see that capacity test if you want, and also down in the description below. I will also put a link down there to the Shenzhen Qishou Alibaba store. They assured me that all of these cells are grade A and are ready to ship. By sea freight to California, it takes about 60 to 90 days, but optionally, if you want it sooner, you can request the package to be shipped by air for an extra cost. I hope this video was helpful for you in building your own battery. If you have any questions, feel free to ask them in the comments below, and I'll see you guys in the next video.